Okay, I think y'all know what I look like, so you don't need to see my mug up there on the screen. I don't think to make this meaningful. But what we're going to talk about is electric field, and look at this definition of electric field that your slide gives you. It says the electric field, notice it's a vector, is equal to the force on Q, which is the Coulomb force that this infinitesimal charge would be finding, divided by the quantity of this little bitty charge. So you got this big, that's the definition they give. What does that mean? What does that mean? Well, I decided to go somewhere else. It's an electric field, physics. Now, a region around a charged particle or object within which a force would be exerted on other charged particles or objects. So, in other words, this definition is talking more about this guy, okay? This guy right here than this guy over here. I don't know why my arrow changed like that, but it did. All right, so we got it from this guy, is, notice I've got a lot more positive charges than negative charges here. So I've got this electric field around, and if I just draw inside this thing, so the overall charge on this thing is positive, okay? And electric fields leave positive charges and they go towards negative charges. All right, it's one of my, so let's take a look at what the ladybug would say. Let me draw it for you real quick. So here's what it should come up. There it is. Oops, there it is. Uh-oh, I'm running out of paper. No, I got paper. Don't panic. All right, here we go. So in other words, when I have a glob of charge over here, and let's say most of it is positive. Most of the charge is positive, so I'll just draw a circle around. Then I've got these electric field lines that are coming out of it this way, like this. 8. And there's they're all the way around. They're coming out all the way around like this, the electric field lines. Now, if there's more and more of them, more and more electric field lines like this, that means there's a stronger electric field out there. Okay, so if I put a little negative charge out here, and I don't tape him down, he's just a little negative Q sitting out here, he's really small, and then he feels a force going this way. All right, because he's negative, he's attracted to that, and he's going to get right into that electric field, and the effect of the field on the charge, what the field is right here is E is equal to K times all of this charge, big Q, divided by the distance it is basically from the center of that charge, which would be divided by R squared, where this is R. Okay? That's what an electric field is. Now, if I had a positive charge over here, it would feel the charge going this way. The electric field is going out that way, but the force it would feel is also going that way. And the electric field on that charge is equal to, again, the electric constant times all this charge Q in here divided by this distance, this R2, over R2 squared. Okay? And then, if I put them together, then the force is equal to little q, this little q right here, times E. Okay? That's the bottom line with electric fields. All right, I'm going to show you a couple more videos on it, probably 2 more, and we'll look at one homework problem, possibly. I think we'll have time for that.